Alright, this is your rubber band cannon. You'll notice there's a couple different sets of measurements on there. Along the rounded part here are your angles. These are the different angles the cannon is aimed at.
0 is down here. It goes up by 10 increments all the way to the top at 90 degrees.
So as you're firing, you're just going to pull out the pin, and then you can raise or lower it to whatever angle you're collecting data from. Along the nose of the cannon here, you'll see measurements. That's the force. That's how far back you're pulling your rubber band each time. So for different parts of the data collection part, you might be pulling it back to 10, or you might be pulling it back to 20. But we're going to be collecting a whole bunch of data at different angles and different forces to try and get an idea of how far a rubber band's going to go in each of those different cases. Alright, this is what your data sheet is going to look like. You'll notice that we're going to collect a lot of data. Over on the left, it's telling you how to set up your rubber band cannon. So first we're going to use a force of 10 and an angle of 0. And then you'll notice we're going to collect 8 different trials, or 8 different pieces of data. Then you're going to go back, staying at 10 for a force. You're going to change the cannon to 10 degrees. So a little bit higher of an angle. Collect 8 different shots. Then go back and keep going, all of them at 10 centimeters until you've tried all of the different angle calculations. Our second day, or whenever we get done with the first part, now you're going to do it again, same angles, but now you're going to pull the force back to 20, which means you're pulling the rubber band back farther, which means we expect it to go farther. But every time you're going to do the same trial 8 different times in order to collect your data. So here's what it's going to look like on your rubber band cannon. You're going to put the rubber band in the notch at the very end, and then you're going to pull back until you get to 10 centimeters. You want to try to be as consistent as you can each time you do it, so that way your data is as useful and as accurate as you possibly can. So you don't want to just kind of haphazardly do it, otherwise your data won't count for anything. But you're simply going to pull it back to 10, fire it on down, and watch where it goes. Okay? You'll have multiple rubber bands. So you're going to fire several of them one at a time.
Whoopsies.
And then you're going to collect the data. Some are going to go farther than others. That's why we're doing 8 different trials. So that way we try to get as consistent of data as we can. You'll notice at the end of the data sheet, you're actually going to calculate your mean or your average for each one of those. That's what we're going to do in class on Friday. But a couple tips for us. Always keep the end of your rubber band cannon lined up with the end of your tape measure, so it's always at 0. When we talk about how to measure how far it goes, you're always going to go to the farthest point on your rubber band to calculate the distance.
We need to pay attention to this meters. So this rubber band right here is past the 1 meter and probably about 88. So when we write that on our data sheet, we write 1.88 meters.
When you come up to the one that's farther up here, kind of keep an eye on the big red numbers. That's the number of meters. So we went past 3 meters, and then we come up, and you're going to have to do your best to estimate. It comes to about 80, so we would write it down as 3.80 or 3.8 meters in distance. So you're going to record that for each one of them, but you want to be as accurate as you possibly can. One person is going to be the launcher. That's the person actually firing the rubber bands. You want to be as consistent as you can in how you launch the rubber bands. You want to pull them back the same way, pull them back to the same point on the launcher each time, because you want your data to be as useful and as consistent as possible. The other person is going to be the recorder. They're going to record the measurements on your actual data sheet. And then the third person is going to be the person actually finding the measurements. They're going to go along the tape measure. They're going to calculate what the distance was for each of the rubber bands and report that back to your recorder. You'll have multiple rubber bands each time, so you'll be able to fire quite a few of them before you have to go gather them and then come back to do it again.
We need to pay attention that we're sharing these 3 jobs so that our data is consistent. So if someone wants to be the launcher for, I don't know, 0 degree to 40 degrees and do all 8 trials, and then you guys want to change jobs, how you determine who does what is up to you. But please keep in mind what you guys talk about in science, controlling those variables, trying to make your data as accurate as possible. All right. So your job on Wednesday and Thursday is to shoot the rubber bands, both sizes, all degrees and forces, and collect the data. As we go through Wednesday and Thursday, if we're done early, we'll be collecting your packets. We'll be trying to share data amongst the group, but we just don't know how much time we're going to have in the 40 minutes. Friday, we'll give you a little bit more time. Make sure that all of your packets are filled in. Each person is responsible for their own data, so you guys are going to have to share the data and pay attention to who has what packet as they come into class on Friday. And then your job is going to be using a calculator to calculate that mean. That last column is going to need to be finished in class.
All right, the reason we're doing this is you're trying to gather how far does each one of these different settings go. If I pull it back to 10 centimeters, but I go to 20 degrees, how far can my rubber band go? How far would it go if I go to 60 degrees? For anybody who ever golfs, it's kind of like your different clubs. Each club goes a certain distance, so when you know how far away the hole is, you know which club to choose. That's the competition part next week. You're going to be set aside some random distance from the target. You're going to have to look at your data and say, okay, if I want to go 23 or 2.3 meters, what angle, what size rubber band, what force do I want to use in order to go that distance? The more accurate your data is that you collect now, the better data you'll have when you're actually trying to calculate those things for the competition next week.
So the groups who are focused and having these discussions along the way are going to do better in the competition next week than the groups who are just sitting there talking.
Good luck. Have fun.